Welcome. Today we're diving into the world of level shifters, a crucial component in modern electronics. Whether you're working with microcontrollers, sensors, or communication interfaces, understanding level shifters can save your circuits from miscommunication and even permanent damage. We'll explore what level shifters are, why they're needed, and how they work in real-world applications. By the end, you'll have a solid grasp of how to choose the right level shifter for your project and avoid common pitfalls. Let's get started by defining exactly what a level shifter is and why it's so important in mixed voltage environments. Level shifter is a specialized circuit designed to convert voltage levels between different devices. Imagine you have a microcontroller operating at 5V and a sensor that only accepts 3.3V signals. Directly connecting them could cause unreliable communication or even damage. The level shifter acts as a translator, ensuring signals sent from one device are safely and accurately received by another, regardless of their voltage requirement. This simple yet vital function keeps your electronics running smoothly and safely. Let's look at a practical example. Suppose you have a 5V signal that needs to be shifted down to 3.3V without a level shifter. The higher voltage could overwhelm the 3.3V device, leading to errors or even permanent damage. The level shifter steps in, safely converting the voltage so both devices can communicate seamlessly. This is especially important in mixed voltage systems, which are increasingly common in modern electronics. Why do we need level shifters in the first place? The answer lies in the diversity of voltage standards used by different chips and devices. Some chips operate at 1.8V, others at 3.3V or 5V. Their logic thresholds, the voltage levels they recognize as high or low, can vary significantly. For example, a 5V chip might require at least 3.5V to register a high signal, but a 3.3V output can only provide 3.3V without a level shifter. The signal might not be recognized, leading to unreliable communication. Logic thresholds are critical in digital communication. If a device expects a higher voltage for a high signal than what it receives, it may not recognize the signal at all. Conversely, if a 3.3V input is exposed to a 5V signal, it could suffer permanent damage. Level shifters protect your devices by ensuring that each component only receives signals within its safe operating range. This not only improves reliability, but also extends the lifespan of your hardware. One popular type of level shifter uses a MOSFET transistor. Here, how it works: pull-up resistors hold each side of the circuit at its own supply voltage, say 5V on one side and 3.3V on the other. When one side pulls the line low, the MOSFET conducts and pulls the other side low as well. High levels remain at their respective voltages, keeping both sides safe. This method is especially useful for open-drain signals like I2C, offering a simple and cost-effective solution. MOSFET-based level shifters are especially valued for their bidirectional capability. This means they can handle signals going both ways, making them ideal for communication protocols like I2C, where devices need to both send and receive data. They're also cheap and simple to implement, which is why they're so popular in hobbyist and professional designs alike. However, they're best suited for low-speed buses and may not be ideal for high-speed applications. There are several types of level shifters, each with its own strengths and weaknesses. The resistor divider is the simplest, but it's only suitable for unidirectional low-speed signals. Diode clamps protect against overvoltage but aren't ideal for logic translation. MOSFET-based shifters are great for bidirectional low-speed buses. Op-amp or buffer-based shifters handle higher speeds but add cost and complexity. Finally, dedicated ICs offer the most robust solution for high-speed multi-channel designs, though they tend to be more expensive. Resistor divider is the most basic form of level shifting. It uses two resistors to scale down a higher voltage to a lower one. While this method is cheap and easy to implement, it's only suitable for unidirectional signals and can be inaccurate at high speeds. If your application involves fast data rates or bidirectional communication, you'll want to consider other options. Diode clamp level shifter uses a diode to protect against overvoltage. It's a simple solution for unidirectional signals, especially when you need to prevent a high voltage from damaging a sensitive input. However, it's not ideal for logic translation and is limited in its ability to handle fast or complex signals. MOSFET-based level shifter stands out for its bidirectional capability and suitability for low-speed buses like I2C. It's simple, cost-effective, and widely used in both hobbyist and professional projects. However, it's not recommended for high-speed applications, as its performance drops off at higher frequencies. Op-amp or buffer-based level shifters are designed for higher-speed buses, such as SPI or UART, which operate in the megahertz range. These circuits provide accurate and reliable voltage translation but come with increased cost and complexity. They're a great choice when signal integrity at high speeds is a priority. Dedicated IC level shifters are the most robust and versatile option. They can handle both unidirectional and bidirectional signals, support high-speed and multi-channel designs, and offer reliable performance. While they are more expensive, their reliability and ease of integration make them the go-to choice for complex or high-speed systems. Using the right level shifter depends on several factors. First, match the voltage levels between your devices. Are you shifting from 1.8V to 3.3V, or perhaps 5V to 1.8V? Next, consider the number of channels you need and whether your signals are unidirectional or bidirectional. Finally, check the speed of your signals. For example, I2C buses typically run at 100 kHz to 1 MHz, making MOSFET-based shifters ideal. For faster buses like SPI or UART, buffer or IC-based solutions are better. Always start by matching the voltage levels between your devices. Using a level shifter that supports your specific voltage requirements ensures safe and reliable operation. For example, shifting from 1.8V to 3.3V requires a shifter rated for those voltages. Using the wrong type can result in unreliable signals or even hardware failure. Number of channels you need depends on how many signals you want to shift. Some applications require only 1 or 2 channels while others may need 8 or more. Also, decide if you need unidirectional or bidirectional shifting. Protocols like I2C require bidirectional shifters, while SPI or UART may only need unidirectional solutions. Signal speed is a critical factor in selecting a level shifter. Low-speed buses like I2C 100K Hz to 1 MHz work well with MOSFET-based shifters. For higher speeds such as SPI or UART in the megahertz range, buffer or IC-based shifters are necessary to maintain signal integrity. For ultra-high-speed buses, dedicated ICs are the best choice. Let's take I2C as an example. This protocol is widely used for communication between microcontrollers and peripherals. It operates at speeds from 100K Hz to 1 MHz, making MOSFET-based level shifters an ideal choice. These shifters are simple, affordable, and provide reliable bidirectional communication, perfect for I2C's requirements. For faster protocols like SPI or UART, which often operate in the megahertz range, buffer or IC-based level shifters are recommended. These solutions ensure that high-speed signals are accurately translated without loss or distortion, which is essential for reliable data transfer in demanding applications. In dealing with high-speed buses, those operating at tens or hundreds of megahertz, dedicated IC-level shifters are the best option. These chips are engineered for speed and reliability, supporting multiple channels and ensuring that even the fastest signals are translated accurately. While they come at a higher cost, their performance is unmatched for demanding applications. What happens if you don't use a level shifter when it's needed? The results can be disastrous. Signals may be misread, leading to unreliable communication or data loss. Even worse, sending a 5V signal into a 1.8V input can permanently damage the receiving chip. That's why level shifters are not just a convenience, they're a necessity for protecting your hardware and ensuring reliable operation. Without proper level shifting, your system is at risk of data loss and corruption. Signals that aren't recognized correctly can cause devices to miss important information or misinterpret commands. This can lead to unpredictable behavior, system crashes, or even hardware failure. Proper level shifting ensures that every bit of data is transmitted and received as intended. Sending a higher voltage signal into a lower voltage input can cause irreversible damage to your components. For example, applying 5V to a 1.8V input can destroy the sensitive circuitry inside the chip. Level shifters act as a safeguard, ensuring that each device only receives signals within its safe voltage range. This simple precaution can save you from costly repairs and downtime. Sum up, level shifters are essential for safe and reliable communication between devices with different voltage requirements. They prevent data loss, miscommunication, and permanent damage by ensuring that every signal is translated to the correct voltage level. Whether you're working with simple resistor dividers or advanced ICs, choosing the right level shifter is crucial for your project's success. Level shifters are found in countless applications, from embedded systems and IoT devices to industrial automation and consumer electronics. Anytime you need to connect components with different voltage standards, a level shifter is your go-to solution. Their versatility and reliability make them a staple in every hardware designer's toolkit. In the world of embedded systems and IoT, level shifters play a vital role in ensuring seamless communication between microcontrollers, sensors, and actuators. As devices become more interconnected and operate at varying voltages, the need for reliable level shifting solutions continues to grow. Whether you're prototyping or deploying at scale, level shifters are a must-have. Level shifters are the unsung heroes of modern electronics, quietly ensuring that devices with different voltage requirements can communicate safely and reliably. Whether you're a hobbyist, student, or professional engineer, understanding how to select and implement the right level shifter is key to building robust systems. Thanks for joining us on this journey through the world of level shifters. Stay curious and keep building smarter, safer electronics.